Yeah, good morning to all of you. I can see still students are joining. I think almost 50% have joined. Okay, so like tomorrow you are having your exam, so I am going to discuss those important things which can help you. A sort of revision. We have already covered quite a many topics in Python, those conditional and looping, but a few topics which I think we didn't discuss, like which is like important from point of view of exam. So we are going to discuss those topics today. Okay. I'm starting with, okay, still students are joining. I'm waiting for one more minute. Meanwhile, I'm opening the compiler also, so that in case anything we need to uh, show, okay, the coding part and how it works, so it will be more clear if you see these things working. Okay, so let's just give me a minute. Okay. Okay, I'm just almost ready. I think just now 24 of you have joined. That's not an issue. Okay, let's see. Okay, compiler is also ready. Okay, fine. Okay, first I take this. I think we give you one revision sheet also. Later on, I send the answers of the sheet also. There are a few questions which I find myself not okay, but still it's fine. If I find you may have few of me have got the answers, but I just discuss few of the things which are really very important from the point of view of exam. Okay. So okay, I'm showing you that sheet. At the same time, I'm going to discuss the things which are like important from point of view of exam. Okay, so all right. So let's see this. Okay, fine. All right. So the very first topic I'm taking is and we see the same type of questions which are there. Computer system overview. Okay. So in computer system overview, basically you have questions which are related to computer system, okay, and then you need to. I also need answers from you in this discussion, okay. So the very like firstly, see, I don't think any question is there on the uh, as if on the CPU, but yeah, the first, if you look for the answers, we will discuss one by one. See, now the thing is that uh, the very first topic though I'm taking is about the CPU. Okay, so CPU is basically, when we are saying of the CPU, we have three main components are there. Okay, so the three main components which we will see in case of CPU are the your is control unit, okay, control unit, your arithmetic logic unit, and you have a registers, okay. And there is another one which is generally to speed up the execution time, okay. So because if every time we take the data from the RAM, it's basically make the system slow, okay. So there is an inbuilt cache nowadays in the memory in the CPU unit, which makes the thing faster, okay. So basically, this cache memory is basically for all the data which is to be frequently accessed by the system. So this cache is there. Control unit is basically for doing all sorts of signaling operation, basically to execution, to fetching the data. Arithmetic operations are all done by the ALU, and registers are the temporary unit which are used for, while during or performing those operations. Okay. So the correct answer of the first one is D, which is basically to reduce the memory access time. Okay, because see, these are RAMs, SD-RAM, and even heap are the memory areas. Okay, so so don't go for anything which is not we have discussed. Don't think that at all as an answer. And RAM from the memory, how you can make it less. Okay, it's the time taken. So that is the RAM. Okay. that is a RAM. So we are actually want to make the access time from the RAM shorter one, so we use the cache memory. Okay. So next one, okay, I think this is clear, so I'm clearing this one. Okay, let's see, we move to the next one. I think this I directly, I think the second one. Okay, so what do you think the second one is the answer of the second one? Anybody? I think yes, only Shinjo is saying, okay, I got an answer from Shinjo. What about the others? Oh, Shomali has also given the answer and Shrijit has also given. Okay, all right, fine. So, see, okay, the answer is no, it's not a natural language. See, our natural language, we cannot say. Natural language, what I am saying, okay, it's not a kind of a formal programming language, it is a high level language, okay. Again, in this context, I would like you to discuss few more things so that you will be clear about this part. See, when we are saying there is a high level language, okay, which we call HLL, okay. Now it is to be converted into a, what we say, we have to translate it, translate this into what we say is a machine code or low level language, which is required, okay. Now in this context, we need a translator, okay. So translator is also is one of the things which you need to know, is that we have already discussed, we have three types of translator, which are assembler, especially the devices which are for hardware purpose. They are having the assembler are machine dependent, and they convert a assembly level program to the machine level program, okay. So they are slightly restricted one. The one which we are using are two of this, any one of this, okay. One is the interpreter, the other one is the compiler, okay. And obviously which one, you know, is the quite a difference is there in this two. One takes line by line translation and execution, okay. So when we say of the interpreter, it is going to take the line by line commands. And oh, I think it's a mistake, it seems so. Interpreter is like this, okay, okay. So it's a line by line code execution. So okay, it's a line by line translation, okay. Translation is there, and then alternatively it executes also, okay, which is one of the other thing which is it is doing, okay. And when we come to compiler, compiler is like the entire program, it entire program at one go, okay, at one go. And the interpreter as is involved in the process of translation and execution, so it is required, which is not required in case of the compiler. Once it is uh, translated, compiler is not required. You can just execute the program, okay. So these are the three things. And assembler is basically hardware dependent, and where interpreter, compiler are not hardware dependent. I think this topic is clear. So here the answer is high level language program, and which is known as a source program. I think this is clear to all of you, okay, fine. All right, so we come to the next one, which is about the which memory device is generally made of semiconductors. Okay, see, you see, your hard disk is basically. I need some answers from you. Who will give me the answer of the third one? Okay, I've got one answer. I got the answer from Srijit, Dipendu. Okay, I think they are quite fast in giving the answers. Priyanshu has given also. Okay. So without taking any more time, you know, the semiconductor, see, the basically your floppy disk and hard disk are there, the magnetic. Floppy disk you may not see nowadays, but your hard disk has basically a magnetic coating is there, and CD disk, DVDs, they are all optical devices, okay. So they are basic. So what is left is the RAM. RAM is a semiconductor memory, okay. So RAM is the one which is there. So there are different types of RAM: static RAM, and what we say is the dynamic RAM, okay. Basically which we use, the dynamic RAM is more used, though it's takes quite a refreshing of the content after some time. Static RAM slightly is more expensive, okay, but static RAM is only used in the applications where we need to read faster, okay, than the other devices, okay, with the direct access, okay, that is there. So you don't need to go into any technical specification. You just, yes, there is I think a question on, there is not there. Okay, let's see. There is another part which is we call is the ROM. Okay, so basically ROM is used for a different kind of, because ROM is a kind of a non-volatile. Here whatever is the data is there, that data stays. Okay, and especially when you boot your computer, your booting instructions are all stored in the ROM. Okay, random read-only memory. RAM is the random access memory. So this is one. Okay, this one is given, though you don't need to pay too much attention on this topic, which is complex instruction set computer. See, there are basically two, three is reduced instruction set computer. The fourth one, okay, the fourth one, this is a reduced instruction set, and this and complex instruction set. Okay, now the just I tell you this. See, instructions can be made a very complex, okay, and can be made very sense, like a function, okay, a factorial, a function which is a very complex instruction is there. So for a complex instruction you need a quite a level of what we say is the translated into many of the smaller instructions. Okay, where we have a reduced instruction set, where there are very basic instruction sets are there, like plus, minus, divide. Okay, so using those instruction set you are getting a higher instruction set. Obviously complex instruction set computers can perform much complex instructions, or much complex type of programming which is not possible, which for which the reduced instruction set require a quite a programming on the user side to do the things rather than on the hardware. Okay, now we come to the next one, which is the most efficient to perform arithmetic operation, the fifth one. So what do you think the fifth one is the answer of the fifth one? Okay, can you give me the answer of the fifth one which is there? So we are now coming to the data representation. Okay, so yes, yeah, 2's complement. Okay, 2's complement is the most efficient one. Why? Because in the sign magnitude one also, like we have discussed, in a sign magnitude one, remember the sign magnitude one is a very simple one. Okay, let me show you. Okay, let's see. See the number of see, everything depends on the word size. Okay, in a sign magnitude, when you have a sign magnitude, okay, in a sign magnitude, what do you see? A number, let's see anything, let's see 13 is the number. Okay, so and if the word size, let's say it's 8 bits, 8 bits is there, so what will be the 13 means? Uh, you will have 13 is basically 1101. Okay, that is 841, and so you have remaining 3 bits are there more, and one is for the sign. Okay, okay, so one is for the sign. So if we have to represent minus 13, so this will be very simply just in a sign magnitude, this is 1 and rest remaining as it is, there will be no change. Okay, so this is a sign magnitude. Now if you have to do the ones complement, okay, again this ones complement, two's complement is are for the negative number representation. Okay, so in ones complement you will have the same 13 here. Okay, like 0 1 sorry 0 0 and then 1 1 0 1. Okay, so when you come to minus 13, then it will be something like this. Okay, so you will just take the sign here. Okay, remember the sign here also will be 1 and then 1 1 and 0 0 1 0. Okay, this is minus 13. And when you come to the 2's complement, okay, 2's complement, once you know that 1's complement, the 2's complement is a very simple. First you get the 1's complement that we have already got, which is again remember it's 1 1 1 1, and then you have a 0 0 1 0. Okay, so when you add 1 to it, okay, you add 1 to it, so you are getting some result here. Okay, like 1 1 1 0 0 0 0 and 1 1. Okay, so this is the 2's complement. Okay, I hope it's clear to everyone. It's a very simple thing is there. You just have to first convert it into, so firstly the only thing you have to take care, if it's a negative number is there, so you start with the positive number. Okay, and as depending on the number of bit size, what number of bits is there, sign magnitude excludes the sign bit. Okay, if it is 0, then it's a positive, otherwise it's a negative. Okay, I hope this is clear to you. It's a not a very difficult thing. Okay, so negative numbers are represented like this. Fine. All right, I think this topic is clear, so I'm not going to discuss this topic. Okay, so This is I think okay. Now we come to the, if a system is a 64-bit machine, what is the length of each word will be? So what is your idea? What do you think the answer of this one will be? Okay, it's a very easy one is there. If you see, the 1 byte is equal to 8 bits. Okay, so it's if a 64-bit machine is there, so I think from where I am getting from most of the answers, like Priyam, Dipanjan, yes, it's 8. Okay, it's not possible. 4 into 8, 32. This is 64, and this is 16 into 8, which is again a bigger number, so it's not possible. Okay, so 8 byte is the easier one. Okay, now this one we have already discussed. The dash converts the program written in assembly language into machine instructions. Okay, so which converts? Okay, now I think, and you can tell me the answer. Oh, it's a very straightforward. I think this is assembler. There is nothing difficult in this. Don't get confused. If you know the answer, don't think too much complicated. Okay. ROM chips. These ROM chips are mainly used to store dash. So, can you think what is this purpose of the ROM chips? Okay. The system files, root directories, boot files, driver files. Okay, so you can see all these files, system files, your driver files, your root directories, they are part of OS, and there are some instructions which are required for the purpose of loading, which are the boot files. Okay, so boot files are there for the purpose of those written like this. So, but basically it's not kind of file, it's a boot instructions are there which is used for the purpose. So the answer will be C. Okay. Now the memory device which is are used, which are similar to EEPROM are this thing. So if you want to know, this is electrically erasable, programmable, read-only memory. Okay. So multiple times you can use it. Okay. So which one is the closer to this one? Okay. Question number 9, which you can say. Okay, Shijit. So everybody is agreeing on the one answer, which is the flash memory. Flash memory is the answer, which is for this. Okay. Blu-ray devices are not this, memory sticks are also not this one, but basically it's the flash memory. Okay, now we come to which of the following operating system does not what is this, is multitasking. Okay, it's a very simple one. All the Windows this versions allow you to do multitasking. Okay, multiple programs can run at the same time, so the DOS is the one which is not capable. Okay, then we have a multi-programming system. So what is your idea of multi-programming system? Okay, so what do you think is the multi-programming system is there? So your options are this can do the are easier to develop than a single programming system, execute each job faster, execute more jobs in the same time, and are used only one large mainframe computers. Okay, so what is the answer? I think it's a quite obvious one. Okay, multi-programming is basically a concept where multiple program can coexist in the RAM at the same time, and they can be executed. Okay, though it is seemingly look like that you are running all the execution, because computers run so fast, you feels like that song which is played and the printing which is going on at the same time. So answer is C. Okay, I agree with Shomali, Pranaka and Shinjoy. It's C. Okay. Now, this is again a very simple one, which is the maximum, which is the number of bits. I hope I just tell a little bit of this one, because this one, uh, yeah, just I know you people are already knowing this thing. The answer, how many number of bits are required to represent an octal number? See, basically, if number of basically all the octal numbers are like between, if you see a octal number is between, all the numbers are between 0 to 7. So you can take 30 is good enough, and the largest number is 111. Okay, so 3 bits is the answer. Okay, which Shejit, Pranaka, and Dipanjan has given. So anytime see any number, anything is given. Okay, like say like this. Okay, so you can just divide it like this. Okay, fine, and this. Okay, this, and so now you can write it again. And I have already said this is 5. This is 2, this is 5, this is 2, and this is obviously 7. Okay, so this is the number which is a octal number. Okay, remember this is the octal number. And if you try to do something in hexadecimal, okay, hexadecimal, hexadecimal. So hexadecimal, you know, its numbers are from 0 to 9, and for 10, 11, 12, 13, 14, it is A to F. Okay, so A to F, correct. And here whatever you write, okay, so here whatever you write, you just have to here the number of bits is the, for the lowest number 0, 4 bits, and the for a highest number 15 you need the 4 bits. Okay, so anything like, if you have anything like this, okay, so what you can do, you can divide it into 4 and then you can do the operation. Okay, so here, and if it is less, so obviously this will be uh okay, can you tell me the answer of this one? Okay, I'm waiting for you to tell me the answer. Okay, okay, can I get the answers fast? What will be the answer of this one? Okay, if I have done, okay, all right. Okay, is it, why it's taking so much time? It's an easier one. You just have to convert it. Yes, I got it from Dipanjan. Okay, very good. Yeah, it looks simple even rather. Why? Because I, by mistake I put it like the pattern I am repeating. It's okay. So this is one. Okay, everybody knows this thing. This is again 5. This is again 5. This is again 5. And if you come to this one, what it is there? So you are getting 8, 4, 12 and 12 and to 14. 14 means one, so it is E, which you have given already. Okay, so just a little careful, otherwise everything, you, most of you are giving the correct answers. Okay, and the only thing, okay, I think I need to select this one. It's going there. So sometime, okay, I think this topic is over. I think you can easily do this thing as you have understood. A slightly, this one is a bit confusing one, this one. Okay, let me first take you to a little bit up. Okay, so now we are coming to this kind of a octal. Okay, now here you see this one, I just tell you a little, maybe we have not discussed that way. We will not this, but still you need to know how you can do this one, like 417 minus 232. Okay. Now in this kind of a summation, you always remember is that you need to do in a way like, see, it's a binary, it's a normally in the way it we do it in a normal subtraction. So 7 minus 2 is 5. But when we come to A in a normal way, what we do is that we add, if it is 1, then we make it 11. Okay. But in this case, what we do, we add 8 to it. Okay. So if we make it 8 is there, so it will be becoming then 9. Okay. So yeah, so this will be like something which will, this number will be 6. Okay, and then this, it will draw, take one number from here, and this will be becoming like 1. Okay, so 165 is the answer for this one. Okay, and so you can also, like, you can convert these numbers and then you can do the same thing. Okay, so and then you can do this thing. So maybe sometime it will take time. Okay, like if you are converting the number, which is in this case uh, the number is 417. Okay, so you can convert it 417 and 238. Okay, decimal, and then you can convert directly this thing. Okay, so you can get the answer of the same thing. Okay, so if you have a number like 417, so if you take a 417, so 7, and if you convert it into decimal, you are getting 271. Okay, and if you take the number of the two, let's say 232, uh, and you convert into decimal, it's 154. Okay, so it is 154, and the other one, which is 417, and if we do it to decimal, it's 271. So 271 minus 154, you are getting something like this. Oh, 254 minus oh, I think this is a bit of like, wait, this is 417. If I convert into decimal, it's 271, and if I do 271 minus 154, so you are getting something like 117, and if you convert 117, you are getting 165. Okay, So a little bit requirement is there. You need to convert. See, if you are doing this thing, I don't want to spend too much time on this, but it's a very simple one. If you just try it, okay. This will be coming as 154. This is 271, and you when you subtract this one, you get the answer is 117, and 117 you when you subtract and you convert it back, you in octal you will get 165. Okay, so I think I will not say this method will be slightly more. So the you go by the okay. I may forget to tell you, see, whenever there is a MCQ sort of a paper, it's very important that you try to do which questions which are easier for you, you do that thing. If something is difficult, you leave it, because then you can manage the time. It's not that you spend your time doing one particular question and then you find there are quite a many easier questions are there. So in last minute, you may do those questions even not correctly. Okay. All right, now we are coming to the next one. This is the one like, what is your answer of this one? Can you tell me like, express the decimal format of the sign number? Okay, so sign number is there. This is a decimal number is there. So you can see this is 0, 1, 2, 3, 4. So it can be like if you, it's an, the only possibility very easy to see, it's 2. Okay, it's a minus 2 rather, because here 1 is there. Okay, rest of them it cannot be 2. That's very simple. Okay, and if it's 12 like 0, 1, 2, 3, 4, so it cannot be 12 and minus 12. So the only option is this. Sometimes you have to remove the other options. Okay, now the next one, which is a binary, I think, which we have already discussed. I can I get the answer for the 15th one? 15th one, I think the hexadecimal equivalent of binary. What I think there's a question which is there, 094. Yes, this is the answer, but I don't see anywhere answer. Maybe given by mistake, B is written like a 9. Anyway, that is okay. You have written, that's okay. Good answer. Okay. And what is the 16th one also? 16th one is also an entire number, which is the 2's complement of this thing. Okay, we will not give this type of questions where decimal is involved, so I'm leaving this one. So don't need to put too much thinking. I don't know why it's there. So convert 653 to hexadecimal. I think this is the one which is the easier one. Dipanjan has though given the answer is 0. It's okay. Convert 6532. Okay, so this one is the easier one which you can easily do. And if you see, I think I have discussed. I do if you okay. What is the answer you are getting is okay. Let's see. Let me write it one time here. 6532. Okay, so this is the easiest way is to first convert into binary. Okay, so 6 means 110, 5 means 101, 3 means 011, and 2 means 010. Okay, now you take it the 4 bits here like this, then make a 4 bits here. Okay, so this is coming to this is 8 4 12, 12 plus 1, this is 13 is coming, and this is what is 5, and this is, oh, it's the answer you have given D5. Oh, everybody is saying this answer is 10. So there's no, so answer is C. So there's no anything. Input devices that are used specialized in contain magnetized particles of iron oxide. Okay, this one you can see, can tell me what is the answer for the 18. Okay, so magnetized iron oxide particles, especially, you know, this is a MICR, this is magnetic ink character reader. This is basically is especially in you see those bank checks where you can find. Okay, next thing is okay, let me this clear this thing, and okay, fine. So first 28 characters are both same in ASCII is whether it's a true or false statement. Okay, so you know it's true because it's just as 7 and 8 are just extended. It has 128, it has 256 are there. Okay, in n both the magnitude 2's complement of positive and negative numbers. Okay, so positive and negative numbers separated by using dash. Okay, so how will we know this thing about the sign magnitude and 2's complement is there, both the numbers? What is the one thing which makes negative and positive numbers different? Yes, very right. It is the most significant bit which is on the what I say, the left side. Okay, so which is the MCB, most significant bit. So B is the answer. Okay, which is capable of recognize a specified type of marks by a pencil or pen. Okay, so this is the we can, you can say this is a OMR. I'm not going to discuss. So which of the following gate give you zero when both the inputs are one? Okay, so give you zero when both the inputs are one. Okay, so which one you think is the one which is can give you this answer? Okay, so can I get anybody telling me? Yes, this is the very simple one, NAND gate, because NAND gate is just reverse of the AND gate. Okay, so okay, you see, I'm not going into this part. Okay, SOP expressions, you don't need to study that much. Okay, this reduction, I think you can say this thing, you can go for this one, but it is not required. The SOP, incorrect SOP expression. Okay, so SOP is sum of the products. Okay, so which one you think is the sum of the products in this case? Okay, which one is not a sum of the product? I think it's a very clear if the B is there. Okay, but you don't need to pay too much attention to the SOP part, but let it be. It's a very simple one. This is the part. Now the expression A plus BC is in the form of reduced. Okay, this is, I think, very simple. This is you know, it's a distributive law. So A plus B and this thing. Okay, and the complement of this entire thing. Okay, so the complement of a thing you can do, see, this is using simply the De Morgan's law. If I can show you a little if you want, but I don't think it's a slightly waste of time. But since anyhow, you see, it's this is x complement y complement z plus xy. Okay, if you do the entire thing complement, okay, this is the entire thing complement. So you know this plus will be your x complement y complement z. This entire thing will be again complemented. Okay, and this dot this x y is again complemented. Okay, and you can write this thing if you should make it. So it's x plus y plus z complement, and this is x complement plus y complement. Okay, so this is the thing. I think Dipanjan has given the correct answers, and I think which one is here, it's slightly, you have to be careful when you're checking the answers. Okay, I can see it's a B is the answer. Okay, so I think this one is also very clear. So let me see. I think I want to start some of the okay, and this time just for your information, there won't be too many things coming from the Python. Okay, so basic Python expression evaluation. Yeah, all the laws you should know. Okay, the 26 one, can you see which is the law, which you can see it here? This is the uh, very simple one. Which one should be the correct one here? Correctly describes, I think Dipanjan has given. What about others? This is a very simple. So all the laws you should know. Okay, so it's a very simple. I think yes, you are right. This is B only. Okay, it's a distributive law, and the other distributive law just now we have seen. Okay, so I mean, you are right. Okay, now what is the output of this thing? So you see the output is here, empty string, zero, they are all false, and other things are all true. So obviously I think what do you think? Oh, everybody is thinking what I am thinking, it's A. Okay, what is the typecasting in the Python? Okay, so what do you think about the typecasting in this thing? So basically to change the data type. Okay, so this is C answer. Now you come to here, that's A16 and this thing. Okay, so what will be the answer of this one? Okay, so if you see the 29th, okay, so the 29th is the answer you are getting is there are three possibilities are there, but let me take you this thing and you see the what you see. There is one possibility. What will be the order of operation here? You do see there are two operations are there. Either this is the first and this is the second. Now which way you go, these operations are there, and yes, you're right. If you go by this, see A mod B. Okay, so 16 by 15. So here you are getting 1, and 1 divided by this integer division. So if you do the integer division, you will get the what the answer. It should be, obviously it will be 0. Okay, because 1 divided by 16 will give you only this. Okay, all right everybody, so the answer of 29 is B. Okay, we are going by this way. Now here you see again you have to follow a certain order. So if you follow the order, it is again left to right order. So what you will get the answer here. Okay, so like 24 6 mod 3. Okay, this is 2443. Okay, so if you look at the answers here, yeah, it's seemingly very easier one which is given, 24 mod 6 3. Okay, 24 and 6. Okay, so what it will be, this is 6 4 4 mod 3. 4 mod 3 is 1, and secondly here it is 24 by 4. So when you are writing the answers, one thing more you should be careful. There are some places decimal is required and some places it is not required. And if both are integers, you see here, like especially this kind of options here, your answer will be in integers only. Okay, so this is 24 4 is again, you are getting here 6, and 6 mod this is again 2, so it will be 3. So A is the answer. Okay, fine, no problem. Okay, now we come to this one. So this is okay. Which of the following is an example of a type conversion? Okay, so if we see the which one is the following is the example of type conversion, can you see? Is there any type conversion going on? So it's a very simple one. Type conversion is float. You can see the A1, which is the correct answer. Now, what will be the output of the Python expression? Okay, x is 15 and 12. Okay, so 15 and 12, again, see, it's a kind of a, what we say, it's a bitwise AND. Okay, so bitwise AND means you go for, let's see, I show you, like if you're 15 and, oh, this is a bit, can I see? Okay, 15 and 12. Okay, fine. So 15 will be, let's see, we write as 111, and 12 will be equal to 1100. And when you do the bitwise of this one, is when both are true, then it is true. So you can see here, this is 1, this is 1. Okay, and these are 2 zeros are there. Okay, so is there any answer like this? Okay, what is the answer? Oh, the answer is given is again in the form of this, so answer is C. Okay, so a little twist is there, but you see that the answer is this one. Okay, all right, so I think this is also clear. So we move to the another one. Okay, fine. Uh, Now, which one of the following is here is invalid? Okay, so when we come to the this one, so which one you to think is the invalid one? Okay, yes, see, underscore is allowed. Okay, two underscore is also allowed. Okay, so the answer is none of the end. So don't get confused. Two underscores are also allowed. One underscore is also allowed. Okay, except for underscore, no other special character is allowed. And you normally, like, you cannot start with the number, and it should be a combination of this thing. Okay. Now, what is the output of 0.1 plus 0.3 is equal to this thing? So what do you think for the 34? What will be the answer is here? Slightly, there is a problem here. It seems to be correct, but basically it happens the floating point answers are not exactly the same. Okay, so this is one problem which you will find. Okay, so here the answer is false. And lastly, 35, which of the following is incorrect? Okay, so here you see the last one, D, which is not possible in a float. You need to 12 and this thing. Okay, so 12 and 34. Okay, this is not a correct one. So answer key also I have given you. Okay, so when you are doing a float number, you need a floating value, then only it can convert. Okay, so the D1 is there. See, more or less, see, this won't be a very difficult paper for you. Please go through it, basic things. Okay, Boolean, and a little bit know more about the what we say of the Boolean, those logic circuits. Okay, logic circuits are very simple, and or and how, if a gate is given, how to get an output.